You guys don't need the calculator. You're in chapter 9. Okay. We are on our way. This is our chapter 9B practice test. Notes. And we're going to look at two in particular. These two problems are arguably the most difficult on here, starting with question 7. Okay. Now, I have to apologize a little bit here. Question 7, you need to use the integral test to do. Okay. We did not learn the integral test. You're not going to be responsible for it on your test. However, since we are doing this, you should see an integral test. So this is an integral test question. Should there be any on your exam, we're just going to skip them, okay? Or I'll give you the answer. So let's take a look at the series that we have. We have the series I don't know. I wish I lived someplace where I'd hear that more often. Okay. We're supposed to use a limit comparison test here. So we need to find out a series that this is closest to. Now I know I usually said to pick a p-series, but how do you pick a p-series for this? Yeah, it's kind of difficult, right? This is not polynomial, or this is not a polynomial in nature kind of a thing. So what I did is I took that and I stripped out all the constants, took out that 2, and basically you get, if you take out that 2, you get 5 over 7n natural log of n squared. Make all those constants into a 1, and you get the series of 1 over n natural log of n squared. And that's what we're going to use for the LCT. So this is for LCT. Okay. Questions on getting that series? Yeah.
How'd you go from the second to the third one?
I turned anything that's a number into a 1.
Why did you do that, or how did you do that?
Because I wanted to find the most basic series to
Oh.
compare to. Now, the problem is, let's write this, problem. We need to solve this before we can do the LCT. Does this series converge or diverge? Because we need to know that going into the LCT. We have no idea if that converges or diverges, or you shouldn't have an idea. Maybe you should have some idea, but we need to show that whether or not this converges. And the way to answer this question, and remember what we're doing is we're doing work before we do the real work. Okay. So this is just supporting work for the LCT. We need to show that this converges, and the way to do that is with the integral test. Okay. So in other words, we're going to analyze this series indirectly by turning it into an integral. I'm just going to start it at an arbitrary number 10. Could be anywhere. Start anywhere. You could put a 2 there if you wanted to. You could put a 1 there if you want to. Actually, I don't think you could put a 1. But you need to pick some kind of number. 10 works just as well as any other. But basically, as you go to infinity, does this converge? If this converges, then the series converges. If this integral diverges, then this series diverges as well. That's all that we need for the integral test. Any questions on the setup? Yeah.
Instead of using the integral test, could you have set a limit to infinity?
You would get 0. That doesn't prove anything. It's not an alternating series, so using just a straight limit cannot prove convergence. Okay. Okay, let's integrate this. Integral from 10 to b, limit as b goes to infinity. Computer's running out of juice. This is chapter 8, I think, work? No, this one right here. Limit as b goes to infinity. That's chapter 8, isn't it? Okay, I'm going to rewrite this as follows for reasons which might become clear later. Verify for me, is that the same thing that we started off with? Same thing? Okay. What's the derivative of natural log of x? U substitution. Does everyone see that? Okay, so u equals natural log of x, du is equal to 1 over x dx. Look how clever that is. I wrote that so you can see precisely where to put the du. Isn't that great? Okay, so this integral becomes, let's just do the antiderivative. The antiderivative of 1 over u squared du, which is the antiderivative of u to the negative 2 du. What's the antiderivative of u to the negative 2? Divided by negative 1, yeah. You got that? Therefore, the limit as b approaches infinity from 10 to b of 1 over natural log of x squared dx, 1 over x dx, that's equal to the limit as b approaches infinity, negative 1 over, what was my u? Natural log of x, great, from 10 to b. Questions on the integral? Antiderivative. Great. Let's plug in. This becomes the limit as b approaches infinity of negative 1 over natural log b minus negative 1 over 10. Okay.
Why is it?
Hmm?
Why is it 10 not natural log of 10?
You're right, it should be natural log of 10. Good work. Good work. Okay, what happens when b goes to infinity? What happens to natural log of b? Well, natural log of b goes to infinity. What does 1 over a number that approaches infinity approach? Okay, so this is 0. I like that. 0 minus negative 1/10, which is 1/10. Does this... Oh, gosh. negative 1 over natural log of 10, which is equal to 1 over natural log of 10. Does this integral converge?
Yes.
Yes. How do I know it converges? Because I get a number. Very nice. Converges. Doesn't matter what it converges to. It just needs to converge. So, what about this one?
It converges to.
This series converges. Does everyone kind of see how to use this integral test? It's unlikely that you will have to use it, but it is there. Yeah.
Do we have to state that the original one is converges, or can we just say this one converges?
All we can say right now is that this one converges.
Okay.
So now that we have that result,
Isn't it natural log of n? Is
yeah,
it-
that should be an n. You're right. I got excited. Now that we have that result, back to the problem. This is all supporting work so you can do the problem. Okay? This is the problem before the problem, or the problem behind the problem. Okay, so we have these two series at 5 over 2 plus 7n natural log of n squared. And we have this series 1 over n natural log of n squared. So we're going to use the limit comparison test. We're going to put this given series on the numerator. We're going to put my series, the one that I've just proven converges, on the denominator. And we're going to see what the limit is. If I get a number, that means they both do the same thing, right? Let's simplify that. That is 5n natural log of n squared on top of 2 plus 7n natural log of n squared. As n goes to infinity, what happens to the numerator?
It increases.
Good, increases to infinity. How about the denominator? Infinity. What does that tell you? Yeah, it tells you L'Hopital. Good. Let's use L'Hopital's rule. Okay. Before you take the derivative, analyze the function. We have 5n times the something squared. That's a product rule, isn't it? Natural log of n squared. That's going to be a chain rule, isn't it? So it's a product rule, and then for the second addend, you're going to need a chain rule. Might be a good idea to always, look at the function before you start blindly taking a derivative. I think that's something we don't emphasize enough. So the derivative of 5n is 5 times the natural log of n squared plus 5n. Hey, what's the derivative of something squared?
2.
2 times the something times the derivative of the something. What's the derivative of natural log of n? 1 over n. Good. Very nice. Okay, what's the derivative of 2? 0. All right, isn't this derivative of pretty much the same thing as the numerator?
Yeah.
Take every 7 and every 5 and replace it with a 7. Isn't that gross?
Just like it.
That's disgusting. Who would do this problem? What kind of a monster would give you this problem?
I don't know.
God,
We must find this guy.
what a horrible person.
Hey, the ends cancel out.
Very nice. The ends cancel out. It's good. Hey. What's up? Is Jerron still here?
No, he's gone.
Okay.
One of the LNs cancel.
Yeah, let's get to the natural logs in a second. Good looking ahead. Okay. Like Griffin says, this n and that 1 over n cancels out, right? So that gives me 2 times 5 is 10, yeah? 10 times the natural log of n. Great. And this is 7 natural log of n squared plus 14 times the natural log of n. We can cancel out one of those natural log of n's. That gives me the limit as n approaches infinity of 5 log n plus 10 over 7 natural log n plus 14. Okay, simplified. What happens when n goes to infinity? Infinity over infinity again. What does that tell us? Again?
This one's a little bit easy.
Oh gosh.
It's gonna be 0 over 0.
L'Hopital. Okay, limit as n approaches it. Isn't this fun? What's the derivative of natural log of n?
1 over n.
Good. So we have 5 times 1 over n over
7 over n.
7 times 1 over n.
It's just 0.
All right, let's make this look official. Therefore, the limit as n approaches infinity of, oh gosh, what was it? 5 over 2 plus 7
Yeah.
n natural log of n squared over 1 over n natural log of n. That's equal to 5/7. What does that mean?
It converges.
What converges?
The series 5.
Not one of them converges. This
The bottom.
the conclusion should be they both converge, right?
Yeah.
Since the denominator series 1 over n natural log of n squared converges, that series converges as well, and I need a drink of water. All of that, and the answer is converges.
It's like Armand buying a diamond ring. Yeah, she just wants to be with him. Go by time.
But you don't have to pay for it. So both phones are free. And if I combine them onto this device, that would be $30 a month instead.
Man, I can't tell you how happy I am every year that Duke loses. Makes me feel good. Oh, hell yes. I went to UCLA. They're not. I'm just tired of Duke. I'm tired of Duke winning all the time. Wow, your bracket's dead. Huh? Nope.
One of their brackets is totally dead because they picked like Ohio State, St. Joseph's. Who else?
You guys had St. Joe in your bracket too, right?
Yeah. He picked all he tried to get all the upsets, and then
You
like
can't.
lost.
Yeah, you can't pick all the upsets. There's no way.
And he's supposed to be the sports guy too.
Okay, let's take a look at 16. We're trying to get all the hard ones out of the way. Okay, so we have f of x is equal to this series, x to the n to the n over n factorial. That looks like a pretty innocent looking series. Man, does that look innocent. We're supposed to find a radius of convergence, so let's do this. How do I find a radius of convergence? Number one, don't jump to the ratio test.
Series.
Is this geometric?
No, it's not.
Okay, not geometric. Now we can go to the ratio test. Good. Ratio test. No. It's a power series. We're looking for a radius of convergence. We go to the ratio test. Okay. Limit as n approaches infinity, absolute value of, let's see, is that x to the n plus 1? N plus 1 to the n plus 1? Ooh. Whoa, wait a minute here. That looks pretty gnarly. N plus 1 times n factorial. I simplified that for you. Make your life a little bit easier. Times n factorial, x to the n to the n. Boom. We want to force that to be less than 1 so we can get a radius of convergence. Let me pause here. Please look for things that will cancel. X to the n. Good. What else? N factorial. Okay.
N plus 1.
Yeah, we'll get to the n plus 1s in 1 second. Okay. So after I've done that, I'm going to get the absolute value of x times the limit as n approaches infinity. Some of you saw it already, and that's really cool. That's n plus 1 to the n plus 1 over n plus 1 times n to the n. Force that to be less than 1. Okay, so some of you saw that this n plus 1 and this n plus 1 in the numerator, we can cancel out one of the powers. That is super convenient. They have the same base. We have two functions with exponents with the same base. We can cancel. You get the absolute value of x times the limit as n approaches infinity of n plus 1 to the n over n to the n. Now, what a conundrum that one is. Okay. The numerator is infinity to the infinity power. The denominator is going to approach infinity to the infinity power.
But wouldn't the top go faster?
Will it grow faster enough?
Because it's plus one.
That plus one really doesn't mean a hill of beans. Once you get to 1,000,000, right?
I guess, yeah.
Once you get to 1,000, that extra one is not gonna mean anything. So we need to do something else. Do you remember what to do when you have a power and a limit?
The P series?
No. I'm just talking about the limits.
Uh,
Okay. So this is now a side problem.
You know,
You don't want to spoil the fun?
no, I don't.
Again, this is a side problem. My geometry teacher, when I was in 8th grade? 9th grade? He would call this a lemma. It drove me crazy. A lemma.
Why?
Which, well, I guess that's what the Greeks called it, a lemma. Basically, it's a problem on the side. Let's take a look at this limit. You notice in the first problem we did, number 7, there was actually a large lemma as well, right? Large side problem. It's a problem within the problem. The inception problem. Is this equivalent to this? That's equivalent to that, isn't it? And verify for me that that's equivalent to 1 plus 1 over n to the n power. Okay, now, if you remember what this limit is, if you look at it, yeah, this is the definition of E right here. You would have to memorize that.
So 1 plus 1.
We're not. I'm going to assume that you didn't memorize that.
Okay.
Okay, and we're going to do the following. We're going to say y is equal to 1 plus 1 over n to the n power. We're going to say the natural log of y is equal to n times the natural log of 1 plus 1 over n. Ah, do you remember this?
what are we solving for?
The limit as n approaches infinity of the natural log of y is equal to the limit interrupting ISIS. Okay, now we're going to work on the right side here. As n goes to infinity, don't I get infinity times, let's see, the natural log of 1 over infinity, so the natural log of 1 is 0. Good.
Fraction.
Oh, okay. I know what to do there. Now I have to turn this into something I can use L'Hopital. Over 1 over n. That's now 0 over 0, right? Which is an indeterminate form. So you're going to use L'Hopital's rule. Not just for chapter 8, is he? Okay, so the derivative of natural log is 1 over the something times the derivative of the something. Questions with that, L'Hopital?
Oh yeah. like 3 lines
Mm-hmm.
when infinity times 0.
Mm-hmm.
I thought 1 over n approached infinity or something. By
1
the
over n
rule.
approaches 0.
I thought by the rule it approached infinity.
N is approaching infinity.
Oh, he's saying diverges. So like
Oh,
special case.
diverges. Yeah.
One
So
more
that's
time?
different. Never
Oh, no,
mind.
no, no. We're not looking at a series, though. We're looking at a limit.
Yeah, that's different. Sorry.
All right, so we're going to cancel. And this becomes the limit as n approaches infinity of 1 over 1 plus 1 over n. As n approaches infinity, the second addend in the denominator goes to 0. So this approaches 1. Very good. So the limit as n approaches infinity of the natural log of y is equal to 1. That means the limit as n approaches infinity of y is equal to e. So the limit as n approaches infinity of n plus, what is that, n plus 1 to the n over n to the n is equal to e. Back to the real problem.
Yeah.
Back to the problem. When we left off, we had the absolute value of x times the limit as n approaches infinity of n plus 1 to the n over n to the n. Force that to be less than 1. Right? Now we know this limit is e. So we get the absolute value of x times e. Actually, I'm going to make that e blue so you can see where it came from. Times e should be less than 1. Or the absolute value of x needs to be less than 1 over e. What's the radius?
I left something in my phone. Thank you.
Isn't that amazing?
No, it's just A.
Okay, you're not supposed to like these problems. Okay, these problems are really not fun. I mean, they're fun for me, but I can see probably not fun for you. Can we go to part B?
Would they put some of this in AP test?
That's a really good question, actually. This is definitely more difficult than what you're going to see on the AP test. Okay? It's very unlikely you'll have to use a L'Hopital's rule, or you'll have a difficult limit inside of a ratio test. Part B. Use the first 3 terms of the series to approximate f of -1/3. Okay, this is where things get easy. Okay. What is the series f of x? Can someone give me the first term? When n equals 1, you get x. When n equals 2, what do you get? 4x squared over 2 factorial. Good. Don't do me a favor and don't simplify it for me. We're just going to write it out. What about the third term?
27
Over 3 factorial. Great. And because I know I'm going to need it in the next problem because I read ahead, what is the fourth term?
256 x to the 4th over 4 factorial.
Now that green term is not necessary. I'm writing it there because I know I'll need it for part C. Okay, let's simplify that now. F of x is equal to x plus 2x squared plus 9/2 x cubed plus 64 over 3, 32 over 3. X to the 4th power. Yeah.
On your test, if we know that we have to use the fourth term for the next problem, if we put the brackets, is that okay?
Yeah.
Will
Put-
it work on the AP test or will they?
That'll work on the AP test. Okay. You know, I'm kind of messing up just slightly. I know this should be approximately equal to because we're truncating our series. Okay. So f of negative 1/3 then, that's going to be equal to negative 1/3 plus 2 times negative 1/3 plus 9/2 negative 1/3 cubed plus 32/3 negative 1/3 to the 4th power. Okay. I'm going to simplify every term now. Which one should be squared? Second one? Sorry about that. We got f of negative 1/3 equals negative 1/3 minus 2 over 9 positive minus, 3 cubed is 27, 27 times, no wait, hold on, 2 of those, that's negative 1/6, right? Green plus, let's see, 32 over 3 to the 4th times 3 is 3 to the 5th. 9 times 9 is 81, so 243. Okay, and this is where I'd keep that, and to answer Michelle's question, I'd stop here with the green, and I'd just continue with the black part. Therefore, f of x, f of negative 1/3, is approximately equal to, what is this? LCD is 18?
Yeah.
So negative 6 plus 4 minus 3 over 18. F of negative 1/3 is approximately equal to, what is that? Negative 5?
Yeah.
Negative 5 over 18. And that's the end of that. The hardest part here is the math, right? That's the dangerous part also. Part D. Okay. Series is alternating. I'm sorry, it's C. Series is alternating. So the error is less than the 4th term. That's all you need to write.
How do you know when it's going to be less than the fourth term?
Because it's alternating.
So anytime it's alternating,
It-
it's always less than the fourth term?
No. It's always less than the first unused term
Oh, from the second.
from the series,
Okay.
which is why we calculated it already. Okay?
Like what it is.
Yeah, we're not done yet.
Oh, okay.
Okay. So, the first 3 terms was a 3rd degree polynomial, right? So the third degree polynomial evaluated at negative 1/3 minus f of negative 1/3 is less than that fourth term, which we did in green, which is less than 32 over 243. Or another way of writing it is the error is less than 32 over 243.
Which one do you prefer, sorry?
Either. The only danger is I want to make sure that you recognize that P3 minus f of negative 1/3. Yeah, Matt.
Will there ever be a case where it's not alternating?
Yes.
Will we have to?
Yeah, you should know how to do it.
Okay.
Okay. It's like question 2011.
Okay.
Possible.
So what is the error if it's not alternating?
It's the next term in the Taylor series, evaluated at the point of approximation, and using the maximum of the next derivative.
Okay, so you take f of x and you multiply this.
Let me just put this in the side here then for you, okay? Non-alternating. Non-alternating error. Error. Okay? So P, let's just call it the nth ordered evaluated at, can I call that x1? Minus f of x1. That's going to be less than. Okay. First term, the maximum of the n plus 1th derivative. Times 1 over n plus 1 factorial times x1 minus a to the n plus 1 power.
And isn't the max usually given, isn't what you said?
Yeah. This part right given, usually given, well no, must be you only have to look between a minus x1 and a plus x1. Usually given. And that's where we're going to stop. We've gotten the 2 crazy problems out of the way. We only have 14 more problems to do.
I think we can do it.
I hope we can do it. To help us on Monday, give me a list of greatest hits, so we can address those problems on Monday. And then any problem that's not in the greatest hits, we'll have it hopefully in another class, or we'll just put it up there online anyways. Okay? Thank you.